Okay.
Good afternoon, sir.
Good afternoon. Okay. So last class, this is your first class, or already you've done something?
So first class.
This is our first class.
Okay. In one group, we have little bit. We have started introduction to that basic electronics lab. Okay. So उमेश सर आज कौन करिया पे चाहूचंते
Sir, experiment start कर दो sir.
स्टार्ट कर दो
Sir,
ତେଣୁ ଆଜି ଆପଣ କଣ ଲ୍ୟାବରେ ଅଛନ୍ତି
sir,
ସେ ଆଇଡେଣ୍ଟିଫିକେସନ ଅଫ କମ୍ପୋନେଣ୍ଟସ କରିବେ
sir, ସେମାନଙ୍କୁ ବୁଝେଇଦେବି sir online ରେ.
ହଁ ହଁ ଠିକ ଅଛି ଠିକ ଅଛି so the students already you got what are the experiments we have to perform in this lab the list of experiments
Yes, sir.
Yes, sir.
Yes, sir.
okay so today in that list if you see first experiment is identification of the components or you can see familiarization of components and then instruments already we have studied in theory class what are the component diode resistor capacitor or other components so how it is physically look like and what is the symbolic representation and we have to see its properties means we have to measure its properties like resistor we are using so properties resistance and how we'll measure it so today so Umesh sir will demonstrate the different types of components which are required to design any electronic circuit that he will demonstrate and how you will do the measurement using multimeter or other instruments so he will brief it okay Umesh sir now you can start
Yes, sir.
okay okay so I'm starting recording part record meeting
Okay, today we discuss about the first experiment. The first experiment is the electronic components and instruments.
This call is now being
But today
recorded.
we discuss about only the components. What are the electronic components? And how you identify the different types of electronic components. Electronic components are two types. One is active, another is passive. And resistor, capacitor, diode, that are the passive components, and transistor, IC, that are the active components. But how you identify emitter-based collector of a transistor or anode cathode of the diode or positive negative terminal of the capacitor? And today we will discuss. Visible?
Yes, sir.
Yes, sir.
Yes, sir.
Now you see, this is multimeter. First is the multimeter. Multimeter is a measuring instrument or measuring device. By using multimeter, you measure the different types of resistance value or AC voltage, AC current, DC current, okay, or diode voltage. And this multimeter, this is a digital multimeter. This multimeter has two leads. Two lead or two probe. One is black, another is red. Okay, the black is your negative, and the red is positive. Again, the multimeter, the second figure, the multimeter has 4 points or 4 holes. One first hole already written capital A, and the second one is the small m and capital A, and COM, that is common. And the last one is the V, then symbol of ohm and the hertz. Hertz. That is capital A means that is current measurement, the ampere. The unit of current is that is ampere. When you measure the larger current or bigger current, in that case, connect this point. But when you measure the small current, then you connect milliampere point. Then common is always fixed, and voltage or resistance value, then this point. The two lead, that is black lead always fixed in the common position. Black lead always fixed in the common position. But when you measure the current, then what do you do? Now just you remove the red lead from voltage point and you fix in the ampere range or milliampere ampere point or milliampere point. Only the current case. Only the current case. In ampere means that is larger current and milliampere means that is small current. But other cases when you measure the resistance value or voltage, AC voltage, DC voltage, in that case, your red probe or red lead connected in the last point. Last point. Then another is, suppose you want to measure current. You want to measure current. In that case, your milliamp, the red probe connected with the voltage range or voltage point, but you measure current. You measure current. In that case, your multimeter may be damaged. Okay, the multimeter may be damaged. Then when you measure the current, then first what will you do? That the red probe connected with the milliampere point or ampere point. Then after that, you measure the current. You measure the current. Again, the multimeter has the different types of symbol already written: of, B, ohm. Then one is your diode symbol. Then another is the capacitance. Now see, this is now you see 4 holes. First ranges, that is up, then V, then ohm, then multi diode symbol, then another is, it looks like your Wi-Fi. That is symbol. That symbol is for continuity testing. That symbol is for continuity testing. Then capacitor measurement, then frequency, temperature, then H. HF means that is beta value of the transistor or gain of the transistor. That is microampere. Microampere means very small current or very little current. Milliampere. Then last one is the ampere. That is larger current, small current and very small current. Microampere is very small. Then milliampere is the small current and last one is the ampere, is the larger current. When you measure the AC voltage or DC voltage, what will you do? The red probe, the black probe connected with the common point and the red probe connected with the voltage point. Then after that, you measure the voltage, here. Then your one rotary switch, then you just move or vary the rotary switch and you select the voltage range, then you measure the voltage, DC voltage. Then how you measure the AC voltage? Now just you press the blue button. Already written, that is DC/AC. AC or DC. If you press this blue button, you measure the AC, otherwise you measure DC voltage. Okay. And resistance is same. If you want to measure the resistance value of any resistor, in that case, just you vary the rotary switch and you select the ohm range. Then after that, you measure the resistance value of the resistor. Then another is diode. If you want to measure the diode voltage, in that case, you select that range, that point. Then another is your continuing testing. Continuing testing means, suppose in this multimeter there is two leads or two probes, but you don't know that leads are working properly or not. Then how you check? How you verify the two leads are working properly? In that case, what will you do? Now first you vary the rotary, that is switch, and you select the continuity testing range. Okay, otherwise diode range. You first select. Then after that you press the DCSC button. Okay. Then just you shut the two leads or two probe of multimeter. Two leads or two probe of the multimeter. Then one sound is coming. If sound is coming, that means your two leads are working properly. If sound is not coming, maybe your leads are not working. If sound is coming, that is perfect, correct. If sound is not coming, that is not correct. Then another is for frequency, capacitance measurement, then hertz frequency. Then is the temperature measurement. That is HFE, that is beta value of the transistor or gain of the transistor. HFE. Then how you measure the beta value of the transistor? In that case, what will you do? Actually, transistor is a three-terminal device. Transistor is a three-terminal device. That is emitter, base, collector. First to identify that the transistor is a NPN or PNP. Then after that you identify that pin, emitter, base, and collector. Okay. Then you mark here, that is already written C, B, E, V, C, E, like that. Again PNP and NPN. First you identify NPN or PNP, then after that the emitter, base, collector of the transistor. Suppose your transistor is NPN, then after that again you identify emitter, base, collector. If emitter, base, collector you identify, if emitter, base, collector identify, then you go to the NPN side, and B means base, C means collector, E means emitter. Just you fix the BCE point, then after that you see the beta value in the display of the multimeter. Okay. Then another is your microampere, when you measure the small current. That is milli, and last one is the ampere. And basically one here, that is continuity testing. The continuity testing, symbol is like this. This is continuity testing. Then how you test the continuity? Suppose this is multimeter, this is display, and this is the rotary switch. And in this case, here, that is the diode symbol, and another is this symbol, that is just looks like a Wi-Fi. Then the rotary switch just you vary and you select this way. And here one blue button, that is AC/DC, and this here AC. When you test the continuity of the lead or probe, then you just press the AC/DC button. Then after that, how you check? Here is 2 points. One point is common, COM, common, and another point is, that is V or ohm or SZ or capacitance measurement. The common position is your black lead. One terminal connected is the common position, then another terminal of the black lead connected with the red lead. This is another is red. Just you connect both. Now short circuit. If the two leads are correct, then here one sound is coming. one sound is coming. That means two leads are working properly. If sound is not coming, that is not working properly. Then 5, not only the middle portion of the any lead or any probe will be broken or damaged or broken. In that case, no sound coming. In this procedure, just you test, you check the probes. You check the probes.
Excuse me, sir. Sir, here why we short circuited the two wires? We should apply battery here, no?
Battery? No. Here short means just you check the probe. Probes are working properly or not. In that case, here is short. Hello.
Yes, sir.
No, actually here is battery is not necessary. Battery already in the what multimeter. That's two pencil battery. But in this this symbol means what? There is such continuity testing of any connecting wire or lead, anything. That is for continuity testing. Suppose you take a one big connecting wire, suppose 10 meter long. The wire long is 10 meter. 10 meter. Okay. This is 10 meter. How you check this where it's working properly? In that case, what will you do? The first side and the second side. First side and second side. The first side you connect the common point, and the second side you connect the voltage point. Okay, then after that you vary the rotary switch and select in the which looks like a Wi-Fi. Then after that you press the ACDC button. If the sound is coming, that means your working your wire is good, not broken. Wire is good. If sound is not coming, maybe your middle portion of the wire is broken.
Okay, sir.
Are you understood?
Yes, sir. Okay, and any doubt in the multimeter, you ask me. Otherwise, we start another components. Starting the components. Sir, here in the NPN or PNP, that section, why there are two emitters? There should be only one, no?
Maybe it is very easy to fix in the multimeter.
Okay.
Sir, please show in this picture how to join the probes.
Where?
So you said now we have to join the probes to so that it should work.
Oh, okay. So just the symbol of the Wi-Fi. Hello.
Sir. First we have to take it to that, na, to that diode.
Yes. No, when you check the continuity, then you select the diode mode, and but here one blue switches, press switch blue. Then you press that. Then after that, actually, you know, like this. Physically, actually, physically is like this. Your lead, then approve, like this. One is black, then another is red. This is your connected with the multimeter. ये multimeter hole. This is multimeter hole, and another is multimeter hole. Now, Here this is black probe, and this is the red probe. This is the red probe. Then how you check these two probes are working properly? Then you go to, if you see the multimeter, and you rotate the variable switches and select the diode mode. And after that you just press the AC and a DC. Then what will you do? One is common, another is voltage. The first is common, COM, and the second point is voltage, V or ohm rating. Okay. Then just here you search the black lead sorted with the red lead. If the two probes are correct, then in the multimeter one sound is coming. The multimeter one sound is coming. Sound is coming means that two probes are working properly. No damage. No damage. If you damage,
Yes, I got it.
if you damage, there is no sound. No sound. Otherwise, how you check in single probe? Just you remove this probe. Okay, just you remove the red probe. And the black probe, another terminal, sorry. Black probe, another terminal connected with the voltage point. This is the second side of the black probe. Then if sound is coming, probe is correct. If sound is not coming, probe not correct. Otherwise, the middle portion of damage or broken. Now you understood? Hello?
Yes, sir.
Okay, any other doubt in the multimeter? Otherwise,
Sir,
you
what
start.
are those RT, RST switches means above that?
Oh, that are the reset switch. Reset means starting from the starting point. Reset.
And
Then
all the
humidity.
other switches that REL, HOLD hold.
That is humidity for frequency measurement, temperature measurement. Here is one point. This is temperature plus or minus. For temperature measurement, another connecting wire is just you connect it here, and then you check how much temperature in your room. See, another the real means that is I don't know. Real means what? And hold means that is for hold. That is constant. Hold means that is constant. You got the constant value. And another is your range. Range means you change the decimal point. Decimal point means suppose your resistance value is 1000 ohms. If you press the range button, the multimeter, your resistance value direct here 1 kilohertz. Sorry, 1. Just you change the value 1. If you press the range value, then decimal is here seconds, first 0 after first 0, then second 0, like that. Just you change the value or change the decimal number.
And sir, what was that duty? That button duty?
That is duty. That is for frequency measurement. Hertz. Already that's for frequency measurement.
Okay, sir.
Duty means that is duty cycle.
And sir, how do we measure the temperature using this?
No, for temperature measurement require another what that is instrument. Another not instrument, huh? That is another accessory. It looks like a straight just connecting wire. Connecting wire. Then one side of the connecting wire connected the temperature measurement points. These points. Then another side is one. It looks like a sensor type. It looks like a sensor. Then after that you measure the temperature. When you will come to the college, that physically, then you will see how you measure the temperature by using multimeter, how you measure the gain of the transistor. You will see, but the online class that is not possible to explain it.
Sir, you were telling about the duty cycles.
Duty cycle in the measure only in the actually multimeter is not possible measuring the duty cycle. Or this frequency is possible, but duty is not possible.
Okay, sir.
Actually, when you see the physically multimeter, then you know what is the function of the RST, that's the research, HZ or REL. The next class, I will tell you, then REL, the hold, range, DCAC. But you just know how you measure the value, resistance value, DC voltage, diode voltage. But in this multimeter, you don't measure the capacitance value. You measure the capacitance value in only the nanofarad range, not microfarad or farad, only the nanofarad range. Okay, any doubt? Otherwise, we start the components.
Sir, could you please explain the
Uh,
sound part? How the
again. Hello?
hello, sir?
Yes, sir. Could you
Uh,
please, sir, hold and range again? Sir? I was actually disconnected, so that's why.
hold means that is you got the constant value. Suppose your value, suppose variable, suppose your value will be variable. In that case, when you press the hold button, now your value will be constant.
Yes, sir. So constant it will make.
Yes, constant. And range means just you change the decimal number, decimal.
Okay, sir. Thank you.
Okay, then we start the components. First, you see the resistor. Here, the resistor are two types. One is fixed resistor, another variable resistor. Fixed resistor means the resistance value will be always fixed, no change or no variable. But the variable resistance means you vary the resistance value. Here there are two resistors, fixed resistor, and this fixed resistor is known as, that is carbon resistor. And how you measure the resistance value? You measure the resistance value, that is two types. One is by using color code method, then another is by using multimeter. Okay. Then how you measure? Madam, just a minute. That is two procedure. One is for using multimeter, then another is using that is color code. And here the first register color code starting from this right side actually, not left side. Right side first color is brown, second one is the black, third one is the red, brown, black, red, and fourth one is golden or silver, golden color, golden color. Then how you measure the distance value? By using color code. Yeah. This is the symbol of fixed resistor. And this is the physically resistor. The first color is brown, second color is red, and the fourth color is silver. Suppose silver, gold, silver, and not silver, is gray color. Okay, suppose silver, you consider here that silver. The first color here, brown B, again black, suppose BL, third color is red R, fourth color is that is silver. And what is the resistance value?
10 into 10 square plus minus 10%.
Yes. How 10 into 10 to the 10 square? Here, this resistor is a four color band resistor. Four color band resistor. The first color you take digit or number. The second color also you take digit or number. And third color is your multiplier. Third color is multiplier. M, suppose M. And the fourth color is tolerance. The B means that is 1, brown, then black value is 0, then red, that is multiplier 10 into 10 to the power 2, multiplier, red value is 2, plus or minus 10%, silver, 10%, that is 1, 0, 10 to the power 2, that is 100, 100, that is plus or minus 10%. 10%. This is the resistance value by using color code method. 1000 hertz or 1 kilohertz or 1 kilohertz. Okay. And what are the tolerance? Plus or minus 10%. When you measure the resistance value by using multimeter, in that case your resistance value may be between 1000 10% means that is 900 to 1100, that is ohm, 900 ohm to 1100 ohm. When you measure the resistance value by using multimeter, the resistance value may be between 900 ohm to that is 1100 ohm. Why? Due to that is tolerance plus or minus 10%. Your resistance value may be 950 ohm. Maybe 980 ohm, maybe not exact value. This is not exact value. That is between 900 ohm to 1100 ohm. Then how you measure the resistance value by using multimeter? Now, first in the multimeter, just you select the multimeter. Black probe connected with the common position, red probe connected with the voltage point or ohm point. Then after that you vary the variable switch and you select the ohm range. Select the ohm range. Ohm range. Then after that the two terminal of the probe, just you connect the two terminal of the probe connected with the two terminal of the resistor. Then after that you see the how much resistance value in the multimeter. Now this is multimeter. The multimeter, that is two COM common, and this is the ohm point, and here is your rotary switch. Just you rotate this and you select the ohm range, and here is black one. This is the resistor. Any terminal you connect to any side. The black common. Then after that you see the display, how much frequency, how much resistance value. Let's suppose 1100 ohm. You measure like this. Now all of you understood how you measure the resistance value by using multimeter?
Yes, sir.
Yes, sir.
And the color code, just you mention, just you know the color value. That is black, brown, red, orange, BB Roy, Great Britain, very good writer. That is your color. B, R, O, Y, then G, B, V, G, W. BBROY, Roy, Great Britain, very good writer. Black, brown, red, orange, yellow, green, blue, violet, grey, and last color is white. Then gold, silver, and no color. These three colors are, that is tolerance color. Tolerance color. Okay. And the another case, say second resistor, small resistor, say you just calculate their resistance value by using color code and multimeter, same procedure. But another thing, here are two resistors, one is bigger, another is smaller. Here the size is different. Why size is different? Again, this resistance value depending upon their power, that is, what is the unit of power? That is watt. The unit of power is, that is watt. The bigger resistor is 1 watt resistor, and the smaller one is quarter watt resistor. Quarter watt resistor. Maybe 5 watt, maybe 10 watt, maybe 2 watt, maybe half watt resistor. Now why? Now due to their power or wattage. All of you clear? It's fixed resistor.
Yes, sir.
Sir, we have to connect a probe from any side in the resistor, yes, sir?
Any side.
Okay, sir.
You connect any side. Here is no polarity. Resistor has no polarity. Then you connect any side of the terminal of the resistor. Another is variable resistor. Okay. The variable resistor, here the variable resistor resistance value already written. Here there is two types of variable resistor. One is known as your VC, that is volume control, and second one is your preset. Second one is the preset. Now how you vary the resistance value here? Here resistor, just to see here, resistor. This is the symbol of resistor, and the second figure is the physical resistor. First band, first number, second band, second number, third band, that is 0 multiplier, 4.11. Then these are different types of resistance value here. There are how many? That is 5 resistance value to resistor. That is color code: black, brown, red, orange, yellow, green, blue, violet, gray, and last one is white. Unity, kilo, mega, milli, micro, or nano, pico. This is the variable resistor. This is the variable resistor. This variable resistor has three terminal, and the resistance value already written in the variable resistor. Suppose one example, this resistor value is 100 kilo ohm, 100 kilo ohm. Then how you measure the resistance value? By using multimeter. By using multimeter. This is the symbol of a variable resistor. And this is the physically resistor, variable resistor, three terminal. In the figure just you see here, this is a variable resistor and three terminal, terminal number 1, 2 and 3. And here is multimeter, two leads, one is common, and second one is the ohm, and the variable switch, you select ohm range, and the variable resistor three terminal, just to mention one terminal, middle one is the second, and last one is the third terminal. And this resistance value is 100 kilo ohm. Suppose one example, 100 kilo ohm, and this pot is this rod is known as that is pot. Pot means which is pot? Now this is pot. It looks like a rod type. That is this is one type of variable knob. This variable knob is known as what? Pot. Pot. This is variable pot. When you connect common to third terminal and ohm to any terminal you connect, common or any terminal you connect first here, suppose the common connected to the first terminal and the ohm point connected to the third terminal. In that case, you see the maximum resistance value, that is 100 kilo ohm. Means you see here 100 kilo ohm, not exact value, may be greater than 100 due to some tolerance, not exact 100 kilo ohm, may be greater than 100 kilo ohm, may be lower than 100 kilo ohm. But here an example, that is, suppose you see when you connect first and third, first and last, then you see the maximum resistance value. But when you connect first and second, then after that you vary the pot, vary the pot clockwise direction. In clockwise direction, your resistance value will be gradually increased. Starting from 100 ohm. When you clockwise direction you vary, then gradually 100, 200, 300, 500, up to 100 kilo ohm. But when you That is the anti-clockwise direction. Your resistance value will be decreased 100 kilo to 100 ohm. Otherwise, you connect 2 or 3, first and second, or 2 and 3. Then you vary the hot pot. Then you vary the pot. Then after that, you see the decrease or increase, or you decrease or increase the resistance value of the variable resistance. Clear? Or doubt?
Sir, first, second, and second, third will give same values of resistance.
No, not same value. If you connect first and second, or second and third, then you vary the pot, white pot.
Yes, a clock and
This one. Then after that, you decrease or increase the resistance value.
Yes, sir.
Clear? But when you connect it first and first and third, then
It will
you, yes, maximum resistance value.
Okay, sir. Okay.
Sir, if you connect 1 and 2 or 2 and 3, then it will give same value, no?
But you just rotate the pot.
Okay, sir.
Yes. Then another is.
Excuse me, sir.
Huh.
Sir, will there be labeling 1, 2, 3?
No. Not 1, 2, 3. You just consider first and last.
Okay, sir.
A middle is the middle. Any side, any side you take first, or any side you take last. There is no labeling. Okay, then another resistor. Then how you vary the resistance value? Now by taking a small screwdriver, and fix in the middle. Then after that, vary clockwise direction, anti-clockwise direction. The same procedure. 3 terminal, first, second, last. Then if you connect first and last, then you got the maximum 47 kilo ohm resistance value. If you connect first and second, then you vary the middle portion by taking a screwdriver. Then your resistance value will be decreasing. This is the variable resistance. Clear?
Yes, sir.
Then another is your capacitor. What is the function of the resistor? Why resistor are used?
To control the current.
Increase the current. Yeah.
Yes, the flow of the
Control the
current.
flow of current.
Yes, flow of current. Okay. Then another is a capacitor. What is the definition of capacitor? Or what is the function of capacitor?
It stores current.
Stores electrical
Charge.
energy.
Yes.
Stores
Yes,
charge.
Store charge. Okay. This is a polarized capacitor. Two types. One is polarized capacitor, another is non-polarized capacitor. This is the first one is the polarized capacitor, and the second one is the non-polarized capacitor. Polarized means that is polarity, positive and a negative terminal. Positive and a negative terminal. First you identify the positive terminal and the negative terminal. Then after that you connect any circuit. Suppose you do not identify the which side is positive and which side is negative, but you connect it to reversely. Reversely means positive is connected to the negative of the supply and the negative is connected to the positive of the supply. And after that, what happen? Your capacitor may be blast, may be damaged. Then before you connect the polarized capacitor in any circuit, first you identify their pin, which pin is positive and which pin is negative. But physically, this is the symbol of capacitor, and this is the physically capacitor. Two pin, One pin is small, another pin is big. And here, 1000 milliwatt, 63 volt, 63 volt, second figure. Just I write here 1000 milliwatt, 63 volt. And this is the positive, this is the negative, this side is negative. Positive, this side is positive and this side is negative. So this is the symbol of the polarized capacitor. Right. Now you see, this is the physically capacitor. This capacitor is two terminal, one is bigger, another is smaller. Now you tell which side is positive, which side is negative.
Bigger one positive.
Bigger one is
positive.
Yes.
Third side is positive.
The figure, this is the bigger one is positive and the smaller one is negative. But in the sometimes the two pins are equal. Suppose two pins are equal. Then how you identify? अभी मैं फिगर दिखा रहा हूँ, ठीक है? हाँ, अभी इसमें देखो. अभी now you tell which pin is positive, which pin is negative. Suppose two pins are equal. दोनों pin equal हैं. How you identify positive is negative?
Sir, on the side there is some marking or elevation.
Yes, that is correct. The capacitor. Here. Now you just look the second figure. This is the silver marking. That side indicates the negative. That side indicates negative. Okay. This. This side indicates the negative. But physically this is silver coated or white color. This side indicates bigger one. And what is the specification of this capacitor? Already written, that is 1 microfarad 63 volt. This capacitor value is 1000 milliwatt, that is microfarad. And what is the voltage rating of this capacitor? That is 63 volt. 63 volt. This means it works maximum 63 volt. This is polarized capacitor. Clear polarized capacitor. The polarized capacitor, just to identify their polar terminal, which is positive and which is negative. Now all of you identify the polarity of the capacitor.
Yes, sir.
Yes, sir.
Yes, sir.
And the next one is non-polarized capacitor. The non-polarized capacitor is no polarity. No polarity. Here. The non-polarized capacitor. No polarity. That means any terminal or any side you connect positive or any side you connect negative. No polarity. Another thing, this polarized capacitor is known as, this capacitor is known as electrolytic capacitor. Its name is electrolytic capacitor. This is the electrolytic capacitor, and this non-polarized capacitor is known as your mica or ceramic or this type capacitor or PF. The symbol of non-polarized capacitor is like this. And the physical is like this, just a circle type, two terminal, and just right. Now just you see here, this is a mica capacitor. That is mica or ceramic or disc type. It looks like a disc type, and it builds in a ceramic material, disc type, or PF. PF means that picofarad. Picofarad. This is the non-polarized capacitor. Then how you convert this PF into microfarad? Microfarad. Here already written that is 104. Check here. 104 AEC. That is 104 is their value. And AEC is that is company's specification. Company's specification. That is 104 PF. And how you convert it into microfarad? Microfarad. The microfarad here is 3 number. The first number you take same as your resistance color code. First is number, second is also number, and third one is your multiplier. 1 second is 0. Third is multiply 10 into 10 to the power 4 means 10 to the power 4. 10 to the power 4. That is PF equal to 10 into 10 to the power 4 is 10 to the power 5. Converted into micro means 10 to the power 6 into 10 to the power minus 6. That is 10 to the power minus 1. 5, 6, minus 1 equal to 1 by 10. Point is 1 microfarad. 0.1 microfarad. 104 means that is 0.1 microfarad. Are you understood?
Yes, sir.
Yes, sir.
Otherwise,
Yes,
suppose
that will be 0.1 farad, na?
No, this is a micro, not a Faraday. That is a micro. Why micro? Here you converted into micro. 10 to the power minus 6, na? Micro means what? 10 to the power minus 6.
We converted from pico to
So
micro.
Yes. That is the 104 means that is 104 pico. 104 pico Faraday. That pico converted into micro.
okay, sir.
104, suppose it is maybe 102, suppose 102. The 102 same ये हो जाएगा 10 to the power 2, 10 to the power 2, 10 to the power 2, 10 to the power 3, 10 to the power 3, 10 to the power minus 3. Okay. Then here is 10 to the power minus 3, 0. Then 0.001 microfarad. Clear? Let it clear.
Yes, sir.
Non-polarized capacitor means first one is the non-polarized capacitor, and here you mark that is silver or white marks indicates the negative. That means small terminal. Another side is bigger, and this is the second one is the non-polarized capacitor. And third one is the symbol of the non-polarized capacitor. Here is the polarity of capacitor. Positive, negative, simple. Positive, negative. Now all of you identify the positive or negative terminal of the polarized capacitor. Okay. And then how you converted pico to micro. And the next one is diode. That is PN junction diode, Zener, the different types of diodes. PN junction diode, Zener diode, LED, photodiode. Here there is no photodiode. Here is only 3 diodes. PN junction diode, Zener, and last one is LED. That is the light emitting diode. The PN junction diode. The PN junction diode, just first you identify their positive and negative, P-type material and N-type material, or anode or cathode. Anode means positive and cathode means negative. Then how you identify anode or cathode of the PN junction diode? This figure is 3 figures. The first one is the symbol of the diode, second one is the physically PN junction diode, and third one is the LED, that is Zener diode. Third one is a Zener diode. Middle is simple PN junction diode. And the first one is the symbol of diode. Then how you identify the anode and cathode of the diode?
There is a white circle and black circle.
Yes, the PN junction diode, white circle, that side is negative cathode.
Yes.
Okay. And the Zener case, that is black side is cathode, then another side is anode. But in the PN junction diode works only in the forward bias condition. Forward bias condition means the positive terminal connected with the positive side and the negative is connected with the negative side. That means positive terminal of the source connected with the anode of the diode and the negative of the source connected with the cathode of the diode. Source means that is power supply. Power supply, DC power supply. Positive and negative terminal connected with the anode and cathode of the diode. And what is the function of the PN junction diode? That is rectifier. Rectifier means converted AC to DC. Converted AC to DC.
Sir, is the color code same for every diode or it may vary?
No, same. Not very. Just one figure. Now you just see here, this is the Zener diode. Visible?
Yes, sir.
Yes, sir.
Now you see the left side, that is black circle. Black circle means that is that side is cathode, negative. This is Zener diode. Then another Zener, all Zener are same. ये देखो थोड़ा बहुत पुराना हो गया है. Every Zener black side is actually Zener diode looks like a glass type. That is glass type material. Glass type material. The black circle indicates the cathode, then another side is anode, positive, and the black circle that is negative. And it works in a reverse bias condition. It works in a reverse bias condition. And what is the function of the Zener? it is used for voltage regulation. Zener is used for voltage regulation. Then PN junction diode. Here, this is the PN junction diode. Here. Again, here PN junction diode is two types. One is germanium, another is silicon. If the value is 0.3, that is germanium, or 0.7, that is silicon. That is silicon. The white circle or the silver side indicates the cathode or a negative of the diode, then another side is anode. Diode. And this is the symbol of PN junction diode. Positive and negative. This cathode. PHODE. Cathode. This side is anode. Anode. Then another is a Zener. Zener symbol is same. But here just this side is positive, this side is negative. This is Zener. Okay, now you identify the anode or cathode of the PN junction diode and Zener diode. All of you identify?
Sir.
Huh?
Yes, sir.
Yes, sir.
Yes, sir.
And the next one is LED, that is light emitting diode. Here is it LED. Okay. In the same, in the LED case, two terminal, that is one is bigger and the small, another is smaller. The bigger one is positive and the smaller one is negative. But in some cases, suppose both terminals are equal, then how you identify positive and negative terminal? Now you see. Now you see, the bigger one is positive and the smaller one is negative. Okay, but if two pins are equal, then how you identify which pin is positive, which pin is negative?
Sir, there is elevation on the side of that body.
Elevation on the side.
On the body of that LED.
Yes, that inner side of the LED. Okay.
Yes, sir. Yes.
Inner side. Yes, yes. That is the LED. ये symbol LED का ये कनेक्ट होगा इसमें. This arrow mark. Arrow mark LED. And physically, yeah. LED is like this, look like this, physically. The bigger one is, smaller one is negative and the bigger one is positive. If the two pins are equal, if two pins are equal, then just you look the inner side of the LED, inner side of the LED. This is a big size, another is small one. The bigger part is known as flat side. The bigger part is negative and the smaller one is positive. If two pins are equal, then you just look the inner side of the LED. The bigger flat side is for negative and the smaller flat side is positive. Now you check the inner side of the LED. Here, One is bigger, then another is smaller. And the bigger one is small terminal. Small terminal. And the inner side of the small far side is bigger terminal. Clear?
Yes, sir.
Your LED now here.
Yes, sir.
Light emitting diode is a semiconductor light source. When electricity is passing through the diode, then it emits light. Actually, in the third experiment, you use the LED. LED is thinner and PN junction diode. That is VI characteristic of diode. Third experiment. You use the diode. Here 3 LED, green, blue, and red. The inner side. Next one is the transistor. Next one is the transistor. Transistor is a three-terminal device. Again, transistor has two types. One is NPN transistor, another is PNP transistor. NPN and PNP. First, you identify NPN or PNP. Then after that, you identify emitter-based collector of transistor. And how you identify that transistor is a NPN or PNP? Physically, transistor. One terminal. See terminal number 1 and the terminal number 2. 3. And here is the transistor symbol. The arrow mark indicates emitter of the transistor. The NPN transistor. NPN. And another is PNP transistor. This arrow mark. This is PNP. PNP. The arrow mark indicates that emitter, a base, last one is the collector. Emitter base collector. The same in this case. This is collector, base, and emitter. But how you know emitter base collector of a transistor? How you know emitter base? How you know the NPN or PNP transistor? First, now transistor is a three-terminal device. That means 2 PN junction diode is a one transistor. 2 PN junction diode. Now how? Here, I delete. Two PN junction diode is one transistor. Then how 2 PN junction diode is one transistor? Now this is a one PN junction diode. Symbol of the PN junction diode. Okay. This side is positive and this side is negative. Then you take another PN junction diode. First PN junction diode and the second diode. And the second diode, the right side is positive terminal anode and this side is negative. Now, just you write here the three terminal number 1, terminal number 2 and terminal number 3. The first one is positive P, middle portion is what? Negative. That first diode and the second diode, both terminals are what? Both diode terminal are negative. That is just you write here N, PN, and last one is the positive, PNP transistor. This is a PNP transistor. This is a PNP transistor. In the same, the NPN case, just you reverse the diode. Here. This side is positive, middle portion is positive. This side is the negative, and this side is negative. This is the NPN transistor. NPN transistor. Terminal number 1, terminal number 2, and terminal number 3. Then how you identify in a transistor NPN or PNP? Then what will you do? Now in the multimeter, three terminal. Okay. Suppose terminal number 1, terminal number 2, and terminal number 3. And this is a multimeter. The multimeter, that is 2 points here. One is common, and second one is the voltage or ohm point. And here, the rotary switch, just you rotate the rotary switch, and you select the diode mode or the diode range of the multimeter. In the multimeter, you select in the multimeter, black is fixed in the common position, red is fixed in the voltage point position, and then you just vary the rotary switch and you choose the diode mode in the multimeter. Then after that, what will you do? Suppose the black leads are common. Black lead, this is black lead, you just connect the second, suppose first terminal. Black is connected the first terminal, and the red lead connected with the second terminal. This is red lead connected with the second terminal. That means just you write here 1, 2, 2. 1, 2, 2. Okay. 1 is negative, that is black lead connected with the first terminal, that is N. Black is N. And the second terminal, you connect a red lead or a red probe, that is P. You just write here P, and you suppose you got some voltage, suppose 0.613 volt, example. Huh? Okay, then you just reversely, you connect reversely 2 to 1, 2 to 1. 2 to 1 means if this red probe connected with the pin number 1 and the black probe connected with the pin number 2, change हो जाएगा. ये 1 the black lead connected with क्या हो गया? Okay, the black is connected with the 2 terminal. क्या हो गया? And the red connected with the now 1. The 2 to 1 is 0 volt. Now why 0 volt? That is reversely. Now 2 is negative. चल क्यों नहीं रहा है? Now 2 is negative and 1 is positive. Okay, 1 is positive. Here there is no voltage. You got the OL. Okay. Now you connect 2 to 3. 2 to 3. Two is now it's connected here to and the black is connected with the 3. Okay, just you write here 2 to 3. 2 to 3, that means 2 is positive P and 3 is negative. Here you got some voltage that is point, suppose 612 volt. Again you reversely 3 to 2, that is OL, and 1 to 3 OL, and the 3 to 1, that is also OL. Okay. And just you look the 2 here, 1 to 2 and 2 to 3. You got the some voltage. Again बोल रहा हूँ. P terminal, and this is the multimeter. This is the diode symbol, the multimeter, rotary switch, and the black is connected with the terminal number 1, and the red is connected with the terminal number 2. 1, 2, 3. Now 1, 2, 2, you got some voltage 0.613 volt. That is 2 to 1. That is OL. 2 to 3. You got some voltage 0.612 volt. Then 3 to 2 OL. 1 to 3 OL, and 3 to 1 OL. Okay. 1 to 2, 1 is negative, 2 is positive, and here 2 is negative, 1 is positive. that is OL, the reversely. 2 is positive and 3 is negative. 3 to 2, 3 is positive, 2 is negative, that is no voltage OL. 1 is negative, 3 is positive, and 3 is positive, 1 is negative. And just you mark here, this is 1 to 2, you got some voltage, and 2 to 3, you got another voltage. Which pin is common? That is 2. Pin number 2 is common. Pin number 2 is common means that is positive. That is positive. Then other 2 pins are negative. N, P, N. This is the NPN transistor. This is NPN transistor. Now all of you understood NPN transistor?
Sir, what is that OL?
That is overload. That means there is no voltage. Overload. There is no voltage.
Okay, sir.
मैंने मैं देखो अभी that is 2 p-n junction diode is a one transistor. Here just I draw the inner part of the transistor. NPN transistor. No. Very easy. Everything is easy hoga. Now this side connected 1 and this side connected. The middle is okay. Now you see the first point 1 to 2, that is you got some voltage. That means negative is connected to the negative of the diode, and number 2. Number 2 is positive, and positive is connected to the positive of the diode, or red probe connected with the positive of the diode. Then you got some voltage. Then another case, reversely 2 to 1. Here 2 is negative, 1 is positive. But actually 2 is what? Positive and 1 is negative. This is the reverse bias. The reverse bias, there is no voltage, OL. Again 2 to 3. 2 is positive, 3 is negative. Yes, 2 is positive and 3 is negative. This is forward bias. Then you got another voltage 0.612 and 3 to 2. Now 3 is positive, N is negative. But here 3 is negative, 2 is positive. This is reverse bias, OL. Then 1 to 3. 1 is negative, 3 is positive. But here 1 is negative, 3 is negative. Both are negative. But you connect one side is negative, another side is positive. Then you got the OL, that is overload, no voltage. And the last case 3 to 1. 3 is positive, 1 is negative. But here both terminals are negative. In that case you got the zero voltage or no voltage or overload. And that's why just you mark here 1 to 2 and 2 to 3. That is 2 is positive and the other rest 2 terminals are negative. This is the NPN transistor. NPN transistor. Now all of you understood this?
Sir, isn't there any other method to find out whether it is NPN or PNP transistor?
Any other method? No.
Okay, sir.
Actually, this method is very easy. Another method is for resistance. You just know the high resistance or low resistance. That is for your what? Emitter-based collector. Identify the emitter-based collector. Actually, this procedure is easy to identify the NPN or PNP.
Okay, sir.
Otherwise, some number NPN or PNP, their number BC107 or BD115, that are the NPN transistor. BC, BD, BC547 or BD115.
Sir, there is no physical distinction between NAPN and PNP. Means every time we have to do this procedure to find out whether it is NPN or PNP.
No. Actually, you identify their number. Their number means their value. Here, this resistance value is BD115. Their number BD115 means that is this NPN transistor. Then again, what do you mean by D? What do you mean by D? D means silicon. Then if A means germanium, and C means that is power, low power, and D means high power. ऐसे कुछ है तो मुझे मैं नेक्स्ट क्लास बताऊंगा, ठीक है। लेकिन just you know their value, then after that you identify this is NPN or PNP. BT115 means that is NPN transistor. Then another transistor is BC107 or BC547, that are also NPN transistor. तो इधर वैल्यू से पता चल जाएगा कि दिस ट्रांजिस्टर इज एनपीएन और पीएनपी।
Sir, why can't we make two terminals long and one terminal short, or two terminals short and one terminal long, so that we can identify NPN or PNP?
No. Here actually short means what?
Short means we can take
Length.
or long means N.
Sir, actually,
Yes, sir.
No. The transistor, the three terminals are equal, no, not bigger and smaller. All the terminals are equal.
Okay, sir.
Here, this is the transistor. All three terminals are equal. ठीक है गया। Actually, basically, you identify their number or value, which is NPN or which is PNP. Or transistor number.
No, sir, this is only method to find this.
नहीं, अगर तुम्हारे पास मल्टीमीटर नहीं होगा तो suppose
Sir, without multimeter, we cannot distinguish between NP and PNP. Yes, sir.
नहीं, without multimeter you also identify that is NPN or PNP by just check their value or number. Another procedure.
I think by signals, because NPN switches on by high signals and PNP on low signals.
Yes.
So by switching on or off, we can also distinguish between PNP and PNP.
Switching on means you require another one power source.
Yes, sir. And it will provide high signals.
Suppose you have no power source.
Then we cannot distinguish. So, yes, sir. Power supply is needed.
Yes.
We need to memorize those numbers to distinguish NPN and PNP.
If possible, then you just remember that number.
Okay, sir.
Remember means बहुत सारे माने many numbers. And how you know that number is NPN or PNP?
Sir, what do these numbers signify? That BD125 CD.
I tell you, that is B means that is silicon, D means that is some specification of transistor. Some specification of transistor means starting from A. A means that is germanium type transistor, B means silicon type. Here starting from B, B means that is silicon type. Okay, and another is D. D means that is some high power. D means high power और लो पावर ऐसे कुछ है लेकिन श्योर नहीं है आई एम नॉट श्योर C means that is high power transistor, D means low power transistor, and another is EF, high frequency and low frequency ऐसे कुछ है ठीक है otherwise just you better search in Google.
Okay, sir.
हाँ लेकिन वो कहाँ just a minute. Let's try. No. Okay, the next class I will tell you how you identify the NPN or PNP register with that multimeter.
Okay, sir.
Okay, sir.
Sir, can you share the PPT with means which you were showing? It would be helpful for us.
Which PPT?
Yes, sir. Yes, sir. In the Google Classroom.
This PPT today I will upload it in the Google Classroom.
Okay, sir. Thank you, sir.
Okay, अभी NPN you identify the NPN and PNP. Then after that emitter base collector of a transistor. Emitter base collector of transistor. Pin is common, that is base. If pin is common, that is base.
Middle one, yes.
Yes, middle one is common. 1, 2, 2 and 2, 2, 3. Pin number 2 is common, that is base. Again, just you mark here voltage 0.613 and 0.612. That is 0.613 is high voltage and this is lower voltage 0.612. So pin number 1 is emitter and pin number 3 is collector. Clear? Which voltage is higher, that terminal is emitter, and which voltage is lower, that terminal is collector.
Yes, sir.
Understood?
Yes, sir.
Pin is common, that is base. Okay, that is transistor. And the last one is the IC. The IC here. IC means this is the integrated circuit. Integrated circuit. The electronic controller on off switch. IC. This is the symbol of IC. The IC has the many terminals. Then how you identify which terminal is 1 or which terminal is 2, 3, 4 here. Now this IC has 8 pins, 8 number of pins. The lower side is 4 pins, the upper side is another 4 pins. Totally 8 numbers of pins. In this case, how you identify which pin is 1, which pin is 2, 3, 4, 5, 6, 7, 8. Otherwise, maybe IC has 18 pins, maybe 100 pins, maybe 15 pins. In that case, how you identify the IC pin? And now here the IC the left side of the IC, there is one cut position, that is cutting position. That cutting position is known as notch. The cutting position is known as notch. Then lower the notch, you count pin number 1. Pin number 1. This is left to right. Lower side is left to right, and the upper side is right to left. And the symbol of IC is here like this. Okay, like the symbol of IC. And physically IC is like this. One, two, three, 4, 5, 6, suppose 7. Lower side is 7 and the upper side is another 7. 4, 5, 6, 7, 7, 6. Now in this case, how you identify the pin number? Now this is the cutting position. This cutting position is known as notch. Okay, notch. And lower the notch, you count pin number 1, this is left to right. Pin number 1, 2, 3, 4, 5, 6, 7. And the upper side is right to left. 8, 9, 10, 11, 12, 13 and 14. And in some cases, maybe IC has no cutting position, no cutting point. Your IC is straightly and one circle like this. And you consider this circle is known as notch. known as notch. And lower the notch, you count pin number 1. This is lower, left to right, and the upper side is right to left. Now all of you understood
Yes,
identifier
sir.
of the IC pin.
Yes, sir.
Okay,
Yes, sir.
then what is the specification of the IC? Means there a value. The value is already written. Yes. Here it is the 16LTH80A. That is the company's specification. And another is LM741CP. That means this IC number is 741. This IC number is 741. And the 741 is that is your OPAM IC. That is Operation Amplifier IC.
Sir, is it necessary to remember these numbers with
Yes,
their?
only this number 741. Only this number one you remember. Maybe another company specification is another maybe letter. Another letter होगा, लेकिन just you know this number 741. 741 means
Sir, is this same for all ICs?
yes, same number.
741.
741 means that is operation amplifier IC.
Okay, sir.
Another example that is 7400. 7400 means that is NAND gate IC. 7402 that is NOR gate IC. 7432 that is OR gate. Or 7404 that is NOT gate. Like that.
Sir, should we remember all these numbers?
Yes.
Okay, sir.
If you know the number, if you remember the numbers, then you know which type of IC and what is the function of that IC.
Okay, sir.
Okay, in the another thing, this is your online class. Then in the second class, second experiment, that is your RC circuit. The RC circuit you design by using the online software, that is Tinkercad software. Okay, in the next class we discuss about the Tinkercad software. Then another thing, another instrument that is that are the function generator and oscilloscope. The next class we discuss about the function generator and oscilloscope and your online software Tinkercad.
Do you have any task for next week?
No.
Sir, for IC circuit, we have to test it by multimeter or IC tester.
IC tester.
Okay.
IC tester, not a multimeter.
Okay, sir.
Your another component is inductor. All of you know inductor. Inductor means that is a coil. Inductor. Here is no inductor. Actually, in the inductance, your unit of inductance is that Henry. See. That inductor you measure in simple multimeter. That meter is known as LCR meter. Actually, in the LCR meter, you measure the exact capacitance value. But in this multimeter, you don't measure the capacitance value. If you measure the capacitance value, you will not get the exact value. But if you measure the capacitance value in LCR meter, then you got the exact value. LCR, L means inductor, C means capacitor, R means resistor. In that multimeter, you measure the capacitance value or inductor value.
Sir, what is the function of IC tester?
IC tester means just you check the IC of the pins of the IC. That IC is working properly or not.
Okay, sir.
मेरे पास तो IC tester नहीं है. मेरे पास LCR meter है. I have one LCR meter, but I have no IC tester. But when you come to the college, then at that time you will arrange a ICR tester. When you see, I
Okay,
will
sir.
check the IC tester.
Okay, sir.
Okay. The next class we will discuss about the instrument and just read your attendance. It is your first class. ମୋର class ଚାଲିଛି ନା ମୋ class sorry another thing, just in free time in your home, just you search, go to the Google and you just write the Tinkercad software. Tinkercad.
Sir, we have to install that Tinkercad.
No, Tinkercad software is the online software.
Okay.
That is the online software. Okay, ID, responsible to ID 1. Hello. ID 1, ID 2,
Present, sir.
3, 4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7.
Hello, sir. I just due to network, I just disconnected. Sorry, sir.
Okay. What is your ID?
Roll number 101.
Otherwise, just you write in the chat box. Huh?
Okay, sir.
Chat box.
Roll number 01 present.
Yes. 7. ID 7. 8.
Present, sir.
9.
Present, sir.
11. Sorry, 10.
Present, sir.
11.
Yes, sir.
12.
Present, sir.
13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present, sir.
ये ID 16. Present.
Present, sir.
17.
Present.
Present, sir.
18.
Present, sir.
19.
Present, sir.
20.
Present, sir.
21.
Present, sir.
22.
Present,
ID
sir.
23.
Present, sir.
24. 25.
Present, sir.
26.
Present, sir.
27.
Present, sir.
28.
Present, sir.
22 present. 22 present. 29,
Yes, sir.
30,
Present, sir.
30,
Present, sir. Present.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40, 40, 40, Priyambada Unkar, 41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44, 44,
Present.
45,
Present, sir.
46,
Present, sir.
Rohon Das, Rohon Kumar,
Roshan Das present, sir.
Roshan Das, 47,
Present, sir.
48,
Present, sir.
49, Samir Ranjan, present. 50,
Present, sir.
51, Sanjeev Kachi, 51, 52,
Present, sir.
53,
Present, sir.
54, 54, Shivakasi Singh, 55,
Present, sir.
57,
56. Present, sir.
57,
Present, sir. 57.
58,
Present, sir.
59, okay, 59, Sudhanshu Kumar, 59, 4 present, 54.
Present, sir.
61,
Present, sir.
62,
Present, sir.
63,
Present, sir.
64,
Yes, sir. Present.
65,
Present, sir.
66,
Present, sir.
67,
Present, sir.
68,
Present, sir.
69,
Present, sir.
and 70.
Present, sir.
Okay, today I will upload a demo of the online software, that is Tinkercad, and all the manual of the first experiment. And just you try in your
Sir,
home. Hello.
the roll number 40 is present, sir. She get disconnected. Have some network problem.
Sir, 54 also present. She is writing in the chat. Shivakshi Singh.
40% and 54 present. Okay, just in your home, just to try how you design the circuit by using Tinkercad, that is the online software. Then next step is discuss. Okay, thank you. Thank you to all.
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.